Hi, I'm Kim Kenny with the Crewe Astronomy Club, and welcome to bonus lesson number 6, Planning for a Successful Sky Watch. But first of all, before we start lesson 6, we want to thank you for your kind support and comments on YouTube on lessons 1 through 5 on the Crewe Astronomy Club. We've had a great time producing them, and the main goal is to get people started in the exciting field of astronomy, because never before in the history of astronomy has it been so easy to download free software applications on astronomy on your smartphone, tablet, or laptop, where you can take your small tablet and beam it right on up to your screen and make your whole living room or den a full planetarium where you can explore the night sky. But the basic thing is to plan in advance, because the one thing we do hate to hear when people buy a new telescope is that they tried a couple of things, they used it for a week or two, couldn't find anything, and chucked it in the closet, and it's been there collecting dust for the last 2 years. And hopefully lesson 6 will help you really get started exploring the night sky. So let's get started.
Well, this past year, the Crewe Astronomy Club has put on several sky watches and programs on exploring the night sky, telescope use, and basically what to buy. But now we want to make sure you have success on your first night out and getting the most out of your telescope. So the Crewe Astronomy Club proudly presents bonus lesson number 6, Planning a Successful Sky Watch.
So a common statement that we often hear is, our family just bought a telescope and we couldn't see anything through it. What did we do wrong? I'm not sure if it was me or my new telescope was messed up. We only saw some stars. So my question to you is, what was your astronomy group looking for? Were you looking for planets or deep sky? Well, we were trying to find the moon and some planets, but couldn't locate any. We should have made a plan and checked the calendar first for the moon's current phase. Because a huge misconception about astronomy is, any night it's clear, you can see the moon, planets, and stars. And that's completely false. It doesn't work out that way. So don't be discouraged if your sky watch was uneventful and disappointing. So here are some things to consider before you set up your equipment and invite all your friends over for a night under the sky. Is that astronomy is an outdoor activity, so weather and clouds are always a factor. It's seasonal, so you may have to wait a few months for your favorites to arrive. Always plan ahead for a stargazing night. Astronomy is also a family, friends, and group activity, so share your experience. The more the merrier. Have snacks, beverages, coffee, hot cocoa, or grill some hot dogs and hamburgers. Really make a night of it. Also, play some cool space music in the background. You'll have a blast. Be something you remember all year. Because the prime time for stargazing is actually spring and fall. In winter, you have very long nights, good clear skies, 3 great months, but very cold, especially with snow and ice. Spring, 3 great months. Then you're going to take a break in summer. Because in summer, you have very short nights, it's hot, hazy, humid, lots of bugs like mosquitoes. And then in the fall, 3 great months again to enjoy the night sky, so it's not consistent. Other things to consider for sky watches is that most people getting started in astronomy are working or still in school. So your observation times are limited to weekends. We often hear, I have to get up early weekdays, so weekends are my only times to observe. Like a lunar eclipse beginning on Wednesday at 1 o'clock in the morning is hard to observe when you start work at 7 a.m. So I want to take my telescope out again this weekend with my friends, but first we need to do a little planning. So, number 1, check your calendar first for the moon's phase on the night you plan to observe. That's the biggest thing to look at. Remember, a night with a full moon is basically a washout. You get your telescope out, all your friends are out there, all your family, big full moon comes out and basically washes out everything in the night sky. So number 2, go ahead and check the entire month for observing planetary and deep sky. So here we have the moon and planetary the 1st through the 10th of the month. Then we run into moon glare because of the full moon on the 13th, but some planetary the 11th through the 17th. Now we're looking at deep sky and planetary, highlighted in yellow, the 18th through the 29th. Then the end of the lunar month comes and we're back to the moon and planetary, highlighted in blue once again. So the weekend of the 5th is a first quarter moon. This is great. So last weekend was a new moon, so no moon was visible last Saturday. No matter how hard you would have looked, you could not see anything with a new moon. It's on the side of the sun. So this weekend on the 5th would be good for a lunar sky watch, and that's a lot of fun to do. Highlight that on that for a good first quarter moon and bring your friends out. So we're all set to observe the moon this weekend. What's the weather going to be like? And that's number 3. Check your local weather forecast for clear skies. Rain or just overcast skies may cancel your observing plans that night. Well, the forecast calls for clear skies with lows around 55 degrees after sunset. So we'll take jackets, hats, and boot-type shoes to keep our feet dry. That's number 4. Dress for changing weather, especially spring and fall, when temperatures can drop dramatically after sunset. Here in Virginia, we can drop 25 degrees in 1 hour, and it can get very chilly very fast, and you will be uncomfortable. What planets can we see? That's number 5. Check online for planet location along with rise and set times. Some planets may not be visible after sunset for months due to the Earth's position in orbit around the sun. Because there will be times during the year when viewing your favorite planet is impossible. People want to see Venus one night and we can't see it because the sun blocks Venus for 3 months. Another planet that people always wish to see is the planet Mars. So, hey, can we see Mars tonight? Nope, not for several months because the sun blocking Mars for 3 months as well. Plus, we see Mars well every other year when it's in opposition. So while you'll have to wait a few months for Venus and Mars to clear from behind the sun, you look up Jupiter and Saturn and you find out they don't rise until after midnight. So nothing was wrong with my telescope. I just picked a bad time of year to observe the planets after sunset. You go ahead and you look up Jupiter and you find out it doesn't rise until 12:30 in the morning, and Saturn wasn't rising until 2:30 in the morning. So if you stayed up all night, you could have seen something, but that's not the way everyone gets to plan their evening. So as the planets travel around the solar system at different speeds, they will be aligned once again for easy viewing. Here Earth comes around and sees Jupiter and Saturn this year, but we'll have to wait another year for all the inner planets to loop around so we get them all lined up again. And now we've got a great shot of Mercury, Venus, Mars, Jupiter, and Saturn. A few months later, they're not going to be in this alignment, so it is very seasonal. So, let's take another look at how we view the planets from the surface of our Earth. We're going to take our solar system and move it right to the center of our screen. Then let's take a little trip. So as we zoom out from our solar system, we see all the planets orbit the sun edge on, called the ecliptic path. The ecliptic path is where all the planetary orbits are tied together. Now, we are tilted on our axis 23.5 degrees from the ecliptic path of our solar system. The moon's orbit around the Earth is 5 degrees off from the ecliptic path. If the moon was in the ecliptic path, we would have eclipses every month. So our view from Earth is tilted 23.5 degrees. And that's the way we see it. So here's a graphic view of the ecliptic path from Earth. The sun sets, there's the moon, there's that ecliptic path right there. There's the orbit of Mercury, the orbit of Venus, Earth, and we're going to bring the Earth around here and stand on the Earth here as our people are looking at the night sky. And then we have the orbit of Mars going up and around us. Now there's the ecliptic path holding all the planets together, and this is the way we see it. So here is the actual view of the ecliptic path from Earth. The planets follow the same path as the Sun and Moon, just follow the ecliptic path through Mars, Venus, and Mercury. So here's a smartphone video at sunset tracking Venus, the Moon, Jupiter, and Saturn. As you can see, the sun is just set. Draw the line. That bright spot there in the lower right is Venus. There's the Moon directly in the center. And then keep following that arc. There's Jupiter. And then in the lower left, you'll see Saturn pop right up. And there's that beautiful ecliptic path going right across, seeing the planets first, even before the stars come out. So when can we see Venus and Mars again? And this is where it's great to download some software free from the internet on your smartphone smartphone or tablet. Here we're running 1 month per second and lining up all the planets. Look, they're all lined up there to see Mercury, Venus, Mars, Jupiter, and Saturn behind us right there. And when will Mars be in opposition? We'll run a few months earlier and look at that right next to each other. How easy it is to do that too, and easy to find that software. Just go to free internet software right off the internet. So Venus and Mars will be great to view 3 months from now, and 3 months later in autumn, Mars will be in opposition. So we've got a first quarter moon in July right after sunset. Also, Jupiter and Saturn are following the moon in the ecliptic path. Now you're making good plans for a sky watch and calculating the best times to observe the night sky, planning ahead using your tablet or smartphone. So we used our astronomy software to find a great date to observe the moon and down the ecliptic path. We're in the middle of summertime, July 15th at any given year right now, and 11 o'clock at night, now we can see there is the moon and a first quarter. We're following that ecliptic path. There's Jupiter, looks perfect, and of course down the ecliptic path a little bit more, we'll be able to look at Saturn as well. Right there, easy to spot. So we're all set this weekend for some planetary viewing. So with a quarter moon, the moon will be straight up and ready for observing right at sunset. And we can observe the moon during twilight before it gets totally dark. And that's when the moon is very beautiful to look at, especially against a dark blue sky. And your best views are during phases. You can't see anything with a new moon for 4 days and a full moon's a washout. Catch it always during the phases. And remember to aim your telescope at the terminator portion of the moon, where light terminates into darkness, right there where it crosses over. Your telescope view, look at that. Absolutely gorgeous, getting that three-dimensional effect where you get the crater split in half. So people ask us all the time, what's best, high or low power when observing the moon? And we always tell them the same answer. You'll always start, no matter what you're looking at, with your lowest power eyepiece, 25 to 40 millimeter. Then zoom in. So here's 40 times. Then we bring it up to 80 times. Then we'll double that to 160 times. So now we're observing the moon like the Apennine Mountain, 17,700 feet tall, roughly the size of California. Look at that. Absolutely beautiful the way you can see the craters being split in half with the sunlight, giving that real good 3D effect. The further away you go away from the moon, you don't see as much detail, but every night during phases, you can see new features to see and locate on the moon. Just spectacular. So for a school report, what would be a correct size comparison of the Earth and Moon? And we get this asked a lot. We want to use common things you can find around the house or around the school. So here's a fun comparison. The Earth is 7,918 miles in diameter, the Moon 2,159, and the average distance 235,000 miles. So if the Earth were a basketball and the Moon was a tennis ball, you would place them 14 feet apart, and that's a great comparison. So another fun comparison, if the Sun was the size of a basketball at exactly 11.8 inches in diameter, then the Earth would be the eye of a needle at 0.108. Place them 65 feet apart. Round it off, then the basketball would be 12 inches and the Earth 1/10 of an inch for the Sun and the Earth. So locating Jupiter and Scorpio with your finder scope. We just observed the moon. Now we're taking away our constellation lines, taking away the ecliptic, and taking away our labels. We're moving our telescope up to Jupiter now, and once you lock down, all of our telescopes are manual. Once we lock it down, it's not quite exactly in the middle, so now we have to do some adjusting. So now we're centering Jupiter with your finder scope. Once we get it locked in, now we see it at about 10 power, even a couple little moons there, but it may not even be in our main scope. It may be a big blur. So this is why it's imperative to make your finder scope exactly in line with your main scope. Looking through your main telescope, start with your lowest power eyepiece and focus, 40 power. Now, switching from 40 to 80 power, you change from a 40 millimeter eyepiece to a 20 millimeter eyepiece and refocus, keeping it always in the center. Then once again, get a little more detail. Now from 80 power to 160 power, we're changing from a 20 millimeter to a 10 millimeter eyepiece and we refocus. A good clear night, what a beautiful view. Even got the big red spot there. Absolutely gorgeous. Also, don't forget the 1 inch per aperture rule, that for every inch of aperture on your telescope, you will get about 50 times of good seeing. So a telescope that has a 4-inch diameter mirror or lens combination will get about 200 times of clear images before you exceed the telescope's limit. So a 4-inch diameter mirror or lens combination, 4 times 50 is 200 times maximum or good seeing power. So here's a great example of that. We were just looking at Jupiter. So we have 200 max power. We viewed Jupiter at 80 power, and that was great. We doubled it to 160 power. Good. Now if we double that again to 320, we've gone beyond the 200 power limit for this particular telescope, and it's bigger, but it's big and blurry. So after Jupiter, you switch eyepieces and take your telescope back to low power. So now we find Saturn in Sagittarius. We saw the Moon, Jupiter, and now we're going to take away the lines of Sagittarius, and there's Jupiter, there's that ecliptic line going right across, and there's Saturn. We're bringing our telescope up, locking in with our finder scope. Now we're going to have our finder view and our main view. Same type of thing. Start with low power, center, and focus. Switch eyepieces to boost power, center, and focus. In this case also, focus on the stars around Saturn. You get those little pristine stars to show up. Don't worry about the planet so much. If you see those stars going in and out, that's what you can focus on. That's a key. Once you get closer to Saturn, try to split that ring up like the Cassini division. You can see that beyond 200 power. So let's check out some massive stars like the red giant star Antares and the constellation Scorpio. Red and blue giant stars are marvelous to look at and beautiful in a telescope. People often mistake Antares sometimes for Mars because it's in the zodiac path and in Scorpio. In a telescope, absolutely beautiful. So how big are red giants like Antares compared to our Sun? Well, first of all, we'll take a look at our Sun. The diameter of our Sun as compared to Earth. Our Sun has a diameter of 864,340 miles. Our Earth, roughly about 8,000 miles, so just a dot compared to the Sun. So now we're putting our Sun right out in the middle of our solar system and we're viewing it from a distance. Now we have the orbit of Earth, not the planet Earth, but the orbit. We're 93 million miles away from the Sun, double that to 186 million miles. Then we have the orbit of Mars. Next, we have Jupiter's orbit. Now these are not to scale. If I had these to scale, they'd be off the screen, so I have to keep them in proportion so you can see it all within the screen. Then we have Saturn's orbit. Saturn's orbit is huge at 1,781,600,000. And that's the size of Antares, massive, 700 times the size of our Sun. And even stars even much larger, like KY Cygni, huge at 1.3 billion miles in diameter, 1,500 times the size of our Sun. Absolutely massive. So red and blue giant stars make our Sun look small. On weekends with no moon, what dark sky objects can we see? I can check the planisphere for constellations and their deep sky neighbors. Now you're preparing for a deep sky weekend, and this is a lot of fun to do. So the first weekend of the month was great for the moon and planetary viewing. We loved the 5th. The second weekend was a washout because we had the full moon on the 13th. So all these days, the 11th through the 15th, we couldn't see anything anyway. But now the 19th and 26th are good too. The 19th is good, but the moon is rising late. We want a purely deep sky, no moon at all. So we're going for the 26th. So let's get together the 26th for a deep sky weekend. Now you've really set things in motion for looking at really deep sky goodies. So checking July 26 at 9 p.m. or 2100 hours, since they're also listed in military time. So we're on April, we're going through May, June, and now up to July, looking for July 26, 2100 hours. So we're locked onto it. Now we can look at the night sky the way it is in our backyard. We can see Cassiopeia is low on the horizon due north. Almost directly overhead is Cygnus the Swan, Draco the Dragon. Directly overhead is Lyra and Hercules. But now we're looking due south. This is where we want to look. A couple of weeks ago we just saw Scorpio and Antares, but what we're really interested in is Sagittarius. This is the heart of the Milky Way galaxy. This is the hot spot where we want to view. And I found 31 deep sky objects in this area alone. Now we have an observation plan for deep sky on the 26th. And I look at my planisphere between Sagittarius and Scorpio, look at all the deep sky objects. And for deep sky observing, I need it dark and no moon to explore galaxies, star clusters, and nebula. So as I zoom into the Eagle Nebula, I can see this beautiful shape here. Now, what we view is not going to be in color, going to be in black and white, but familiarize with the shapes on your laptop or smartphone or tablet. And a reminder, to see these things, no white light like street lights, porch lights, flashlights, cell phones, and tablets. Also, no flash photography and block your eyes from passing cars. If you take your tablet outside, select night mode on your astronomy programs to preserve your night vision. Once you hit that, everything goes red. You can take any device outside with red light like this and you can use it to explore the night sky. Also remember, when observing deep sky, the wider the brighter. The more light photons you can scoop up, the brighter and better the image will be, whether you're looking at star clusters, or galaxies, or nebula. You want to get as many light photons to create an image. So people ask us, are high-powered telescopes only good for viewing the moon and planets close up? Well, for deep sky, it's fun to use our high-powered telescopes to split star clusters and double stars, like Mizar and Alcor. You can see Alcor just splitting off right here in the handle of the Big Dipper. But as you get closer and closer, there's Mizar A and Mizar B, a double star system that are rotating around each other. Then we look at the Sagittarius star cloud. What looks like a cloud is actually thousands of stars all clustered together. Then we look at M4 in Scorpio. We just looked at Antares a couple of weeks ago, but now as you zoom into M4 star cluster, look at that. Just absolutely brilliant as you see thousands of stars being separated. Then the Wild Duck cluster, what looks like three big massive stars as we get closer and closer under high power, get up to around 150 power, just splitting those stars right on up. Then we look at M35 in Gemini, the beautiful star cluster, just absolutely gorgeous to look at. Love to look at that one. And of course, our favorite in Perseus, the double cluster. And even this program doesn't do it justice. Much more beautiful through a telescope. Let's get Andromeda M31, M32, and M110. With no moon out tonight, we can view many galaxies and nebula in a single view, like the Andromeda Galaxy. Then to the left we see M32, and the right, the galaxy M110. Then after we look at Vega, the blue giant, we can zoom in on Lyra, and between the two stars in Lyra, we can start to pull out M57, the Ring Nebula. Absolutely gorgeous to look at, one of my favorites, especially when it's directly overhead. Early in the morning around 4:30, you may catch the Orion Nebula coming up in the constellation Orion, the brightest nebula in the night sky, and you can split the trapezium too with a higher power telescope. Then of course Charles Messier's first on the list, the Crab Nebula, M1, always a favorite in Taurus the Bull. So all of a sudden you're sitting outside and there's a big flash of light going right over your head. And hey, let's see if we can plan a sky watch around a meteor shower. And that's number 6. Meteor showers are easy to plan around since they come at the same time every year, just like the holidays. Look for eclipses also. And the best way to view a meteor shower is with your eyes. No special equipment is needed. So here's your annual meteor showers. Pause the program if you wish, write down the dates. Also, no moon to get the best experience. And people ask us, why are meteor showers annual? Why do they come at the same time every year? Because as the comet swings around the sun, the solar wind and heat from the sun blows off ice, rock, and gas from the comet, forming its tail. As you can see, as a comet swings around, the sun is blowing it away from the sun in the direction away from the center of the comet. Now this debris is going to stay in orbit with the comet throughout the year. So this debris of ice, rock, and gas travels in the comet's orbit and creates annual meteor showers when the Earth intercepts the remaining comet debris. So that little orange trail, that's all your comet debris. The Earth's going to run into that. And this is where your meteor showers are going to occur at these interception points. So this is exaggerated about the size of these, but I want you to see them on the screen. So annual meteor showers are named after the constellation that the meteors seem to appear from. And this area where the meteors fly out in all directions is called the radiant. So the Leonid meteor shower, the peak night is November 17th through the 18th, and the associated comet is Tempel-Tuttle. And there's the Leo radiant. This is where they seem to fly out in all directions from this center point, and they're going to come straight ahead, overhead, down below. So the Earth is running into comet debris right in Leo's head, and that pinpoint right there is where we seem to be intercepting all this debris. So a group of science students are planning a field trip in the fall. Now they want to see Mars in opposition, the Moon, and as many planets on a weekend from 7 to 10 p.m. Well, that's quite a big order, 4 different things that we need to look at. So with our Planisphere astronomy software and the internet, we can easily calculate a future date to meet these requirements. So, number 1. When will Mars be in opposition? We're going to take our astronomy software. Let's run time forward 1 month per second. So it went through December, January, February, March, April, May, June, July, August, September, and October. There we are, right next to each other. October 2020 looks good. So number 2. We need a waxing moon for evening viewing on a weekend. We bring up October 2020. The 3rd is no good, it's a full moon. The 10th is no good, it's rising after midnight, it's waning. The 17th is a new moon. 24th looks great. So the best date is Saturday, October 24th. Now we can see we'll have a waxing gibbous, looks just like this that night. So now we have our software set for the 24th, October 24th, 2020 looks good. Now we can run time forward from 7 to 10 p.m. to select what we can view that night. At 6 p.m. you see the sun is setting. At 7 p.m. when the program starts, we can now start looking south. We can view Jupiter and Saturn, perfect at 30 degrees altitude. This is great. Next, then we can view the moon at first quarter. And there's the moon right behind it at almost 30 degrees altitude. Looking east, we can view Mars in opposition. This is perfect. Mars is there, but it's a little low on the horizon, but Mars is up already. But we'll wait another hour to view Mars until it gets above 20 degrees in altitude to get the best view. So at 8 o'clock, we can see it's about 26 degrees altitude, and then by 9 o'clock, way up there at about 37 degrees altitude, perfect for viewing. We got our evening plan. So in 5 minutes, we calculated all the requirements for a fall sky watch a year from now. We are all set. Great things to look at. The only thing we can't guarantee is what the weather will be like 11 months from now, and that's something you can never do that far in advance. But we're all set. So number 7, we can bring some refreshments and we can have our first star party, really make a night of it. So for a successful sky watch, let's go over our checklist one last time. So number 1, always plan ahead for a stargazing night. Number 2, use your Planisphere astronomy software or check the internet to line up the planets or deep sky objects you wish to observe during the year. And number 3, check your monthly calendars, all the calendars, and plan around full moons. Number 4, always look for meteor showers or a possible lunar or solar eclipse. Monitor the weather forecast as it gets closer to the event. Number 6, dress for seasonal changing weather, especially spring and fall. And number 7, once you have some observing dates lined up, invite your family, friends, or fellow astronomers over and have a star party. Really make it a great night to enjoy, something they'll remember and talk about years from now. So as we close off Lesson 6, I want to give a special thanks to my good buddy Keith Johnson, always bringing out new and exciting equipment for the general public to try and use so they can get some experience in buying their first telescope. He took these gorgeous photos of the lunar eclipse January 20th, 2019 right here on our farm. Then also a special thanks to my lovely wife Margaret, who's great with the kids, always with her smaller telescopes that the kids can use. Took this beautiful picture of the Mercury transit of the sun. That little dot there is Mercury. Mercury, November 11th, 2019 at 11:30 in the morning. Then there's me, yours truly, Kim Kenny. I had a great time producing this program. Took this great shot of an ice storm in December during sunrise. This is a superimposed photo. And then the 2019 lunar eclipse, the moon that Keith Johnson took, put them together, makes a neat effect. I had a great time, hope you did too. And on behalf of the Crewe Astronomy Club, clear skies, and thanks for watching.